All right, let's take a look at section 2.6, number 8. We're evaluating a limit involving a trig function. In fact, this one is involving sine. Real important here, sine squared of 14t. You need to understand what that means. Sine squared of 14t means sine of 14t all squared. So in other words, we're doing 14 times t first, right? Plugging that into the sine function, getting that output, and then we're squaring it. So it's the same as sine of 14t times sine of 14t. So I've written it several ways here. We're going to use this here in a minute. Now, in evaluating limits, all limits, even limits involving trig functions, if I can plug in directly and get a real number, right, for the functions we're dealing with, then that's the limit, right? In other words, that would mean that the function is continuous at the point we're taking the limit. Not true here. If I plug in 0, I get 14 times 0, 0. I get sine of 0, which is 0, and 0 squared is 0. So I get 0 up top. Of course, t is 0. We get 0 divided by 0, which is indeterminate. Again, that doesn't mean the limit does not exist. It means we've got to do a little work. Now, when we have limits of this type involving trig functions, then we want to use two important limits, one of which, the one we're going to use here, is this one. Those limits can be found on the algebra and trig help sheet that I give you. This is the trig portion. It's got the fundamental identities. It's got the right triangle definitions. It's got the unit circle down here. And then you'll see right here above the unit circle, there are those two important limits. I proved both of these in the lecture notes, but you can use these without the proof now. And there's the one we're going to use here. So we know this limit is 1. So what I'm going to do is I'm going to write this out. I know sine squared of 14t is sine of 14t times sine of 14t. So I'm going to take that sine of 14t over t, and I'm going to sort of peel off that other factor here separate, because this is very close now to this, except I have a sine of theta over theta. Well, I've got a 14t inside here and a t. This 14 can't be factored out, by the way. It's inside the trig function, inside the sine function. But I want to adjust that so that it looks like this. All right. So I've got a limit of a product of two functions. I can write that as the product of limit, provided these two limits exist. Okay. Now this limit here, let me just say this limit here exists already. If I notice as t approaches 0, the sine function is continuous on its domain, which is all real numbers. So I can just plug in directly. I get sine of 0, which is equal to 0. Now, just saying, hey, this is 0, I'm multiplying times something, 0 times anything is 0. That's incorrect reasoning. We have to make sure this limit exists. It does exist, but that is important in general. So just be careful about, incorrectly. Both of these limits have to exist. Now, you can see I've got this limit, and what I was saying is I have a sine of 14t over t. I want it to be sine of theta over theta. So in order to get a 14t down here, I need to multiply top and bottom by 14, which is 1. And so this 14 goes with that t to give me the 14t down there. This 14, I'm going to pull outside the limit because it's a constant multiple. And I can do that provided this limit exists. And this limit now does exist because I can get it to look like that. Basically, by letting theta equal 14t. Okay, if theta is equal to 14t, then I've got sine of theta over theta. And as t approaches 0, if theta is 14t, then theta is going to 0. So in other words, this is just a theta here, a theta here, and a theta here. And now it's exactly in that form, right, to give me a limit of 1. This one here, as I said, I can evaluate directly by plugging in and I get 0. Okay, so all the trouble to show that this limit was 1, kind of a moot point. We've got 14 times 1 times 0, which of course is indeed 0. So now, we have proved that both these limits exist. Now I can apply the fact that I can write the limit of a product as a product of the limits. Okay, so again, kind of long and drawn out. Basically, I talk about this in the lecture video, so you might want to watch that. And I explained going through this process of dealing with this and how you can, sort of shorten up the analysis. But this is how we would show the proof for this. Okay, hope this helps. Of course, if you have questions, please contact me and let me know.